Good day everybody. In this video I will show you how to estimate the Rankine passive and active pressure, and we'll do some example. I already made the video, please watch that one, the link is in the description. That video shows you how to use the technique to estimate the total pressure acting on the wall. So this one will be a little bit more advanced, where we actually look at the active and the passive pressures. So let's look at this example where we have two layers of soil. So this top layer of soil, it has unit weight of 18 and friction angle of 35 degrees. It's 1 meter deep. And below we have another layer of soil which has a unit weight of 20 kilonewton per cubic meters and the friction angle of 30 degrees. And it's also below the groundwater table, which means that this soil is submerged in water. This also means that we will need to estimate pool water pressure. So when this wall, which is inserted in the soil mass, it moves, it will decrease the lateral pressure on this side, on the right hand side. So this is what we call active pressure. And it will increase the pressure on the left hand side, so that will be a much greater pressure against the wall. So this is what we call passive pressure. So we will need to estimate these active and passive pressures, and to do that we need to estimate this lateral stress. So this is the formula. You see that these formulas are very similar. We do need to know this effective vertical stress, but here for active pressure we're going to use coefficient of active pressure, and here on the left hand side the coefficient will be different. It will be for the passive pressure. So let's see how to do that. I have already prepared this sketch, so I already drew these shapes, these triangles on the right and left hand side. So that will represent the force acting on the wall, and this is what we need to estimate. So basically we need to look at the lateral pressure that comes from the soil, and if we have groundwater level, we need to estimate also hydrostatic pressure from water. Okay, let's start with this example, and we're going to start with the active pressure. To do active pressure, we need to know this coefficient of active pressure, and it's given here. So according to the Rankine theory, we can use it, we can calculate it using either function of sine or tangent. Doesn't really matter. We still need to know the friction angle, and the friction angle is given. Please remember that this example is for soil that has only friction angle and has no cohesion. When soil has cohesion, that the procedure will be slightly different. Okay, so let's start with this, the first top layer, which is 1 meter, and we're going to estimate the coefficient of active pressure. I'm going to use the formula that has sine of 35 degrees divided by 1 plus sine of 35 degrees. So that should give us the number of about 0.274. So that will be this coefficient of earth pressure, active pressure. And let's do it for the second layer. For the second layer, because the friction angle is different, you see. So then this means that also this coefficient of active pressure will be different. Again, I can do it using the sine function. So this will be, sorry, minus sine of 30 degrees, 1 plus sine of 30 degrees. So this is minus. So that will give us a value of 0.33. And for this layer, for the second layer, because here on the left hand side we're going to estimate the passive pressure, I'm going to estimate also coefficient of passive pressure. And just for variety, let's use this tangent formula. So it's tangent in the power of 2, and Here angle is 45 degrees plus friction angle which is 30 degrees divided by 2. So that should approximately give us a value of 3. Another way to do that, this coefficient of passive pressure, it's the reverse of coefficient of active pressure, right? 1 divided by 0.33 will approximately give you 3. Okay, so now we have defined these coefficients of active and passive pressures. Now we have to go layer by layer and estimate the lateral pressure. Again, we're going to start with the top layer, which is 1 meter. So I'm going to write it here. We'll start with the surface, 0 meters. 0 meters, we don't have any soil above, so vertical stress is 0, no water pressure, 0. So sigma h is also 0. So on the top of this triangle, I'm going to write here 0. So there is no pressure there, 0. So now we're going to look at the bottom of the first layer, which is 1 meter. And we're going to estimate the lateral pressure acting at 1 meter. So the way that I'm going to do, I'm going to do it through the total stress, effective vertical stress, and then effective lateral stress. There is another way that I showed you in the previous video. You can also check that one. So I'm going to write here from 0 to 1 meters. We have a vertical stress, which is a unit weight 18 times the depth, which is 1 meter. It's 18 kPa. There is no water pressure, right? So because groundwater level starts below 1 meter, so which means that here it's 0. This means that vertical effective stress should be equal to total stress, and it's equal to 18 kPa. Now we're going to estimate this active lateral pressure, and remember we use these effective stresses. So this is a coefficient of active pressure times the effective vertical stress. So that will be the coefficient is 0.274 for the top layer times 18, which is effective vertical stress, and that gives us 4.93 kPa. So here I'm going to write 4.93 kPa. Okay, now we're going down, so now we're going to cover from 1 to 4 meters, so altogether it will be 3 meters. So we're going to do this part. So you will see that this actually is not going to start with 0. So we need to now to find this point. So we need to find this active lateral pressure acting on the wall, and the one that is at the level of the top of the second layer. So I'm going to write here at 1 meter. So we still have water pressure. It's equal to 0, right? We still know that vertical effective stress is equal to 18 kPa. That's what we found here. The only difference is this coefficient of active pressure. So that's why I'm going to write this active lateral pressure. It's the coefficient is now different. It's for the second layer 0.33 times 18, and that will give us 5.94 kPa. So this value will be 5.94. Okay, now we're going to look at the bottom of this layer, because that's where the end of the layer and also end of the this wall. So I'm going to write here at 4 meters. Okay, so let's estimate the total vertical stress. So we have stress that comes from the top layer of 1 meter, and then additional 3 meters of the second layer with the unit weight of 20. So that will give us the total effect, total vertical stress at 4 meters equals 78 kPa. We estimate pore water pressure. So this is where we have groundwater level. So we have 3 meters of water, right? So in this case, I'm going to write 3 meters times the unit weight of water, 9.81. That will give us 29.43 kPa. And then I will round it to 29.4, and the effective vertical stress at 4 meters will be total stress minus pore water pressure. So according to my calculations, it should be 48.6 kPa. So now we are going to find this lateral active pressure at 4 meters. That will be 48.6. That's the effective vertical stress we just found, times 0.33, which is the coefficient of active pressure in the second layer. That will give us approximately 16 kPa. So I'm gonna write here 16. So this point is 16. Also we have groundwater level below 1 meter. So here at 1 meter it will be 0. And we already found that pore water pressure will be 29.4. So this point 29.4 kPa, right? So now we're going to estimate the active pressure acting on the wall. So as I explained in the previous video, we need to estimate the area of this triangular. This is not triangle, it's a trapezoid. We need to estimate area this as well, and also area that comes from this pore water pressure. So the way to do that, it's well, a little bit of geometry thing. I'm going to write it here. Before I write it here, you will see in some textbooks when we look at this one static pressure, what they do, they estimate first the area of this rectangular, and then they add an area of this triangular. So instead of estimating 3 areas, so 1 before 2, 3, they will estimate 1, 2, this will be 3, and this will be 4. So you can do that one. So the way that I'm going to do, I'm just going to estimate the total area of this trapezoid. So I'm not going to do it separated. So that will be, I'm going to write it here. So that's total active pressure acting on the wall. We'll start with the first top layer of 1 meter. So it's half of that pressure at the bottom, which is 4.93, and times the length of this triangle, which is the thickness of this top layer, which is 1 meter. So, okay, now for the second layer, when we look at the lateral pressure from soil, so we're gonna get half. So we use half of this top and the bottom values, which is top value we estimated 5.94, plus at the bottom we have 16 kPa, right? And so we'll take half of that, and we multiply by the length of this shape, which is 3 meters. So that's 3 meters. That's the also the thickness of this layer. And after that, we are going to add hydrostatic pressure. In this case, we have area of triangle, so it will be half times the maximum value which we have at the bottom. It's 29.4 times 3, and should give us 79.5 kPa. So that's the answer. So you can do it this way, or if you want to separate this trapezoid in the rectangular and triangular thing, you can do the same. You're gonna get the same answer. Okay, so that was active pressure. Now let's do the passive pressure. So we're gonna look here on the left-hand side. In this case, we have only one layer. So again, we're going to estimate lateral pressure from soil, and then because the soil is below the groundwater level, so we also estimate the hydrostatic pressure. You will notice that porosity pressure on the left-hand side will be equal to porosity pressure on the right-hand side because the groundwater level is the same. But the effective vertical stress on the left-hand side will be different from the one on the right-hand side because on the right-hand side we have extra 1 meter of top layer. Okay, so let's do the passive pressure. Again, here on the top, there is no soil, there is no water. We put 0 here. But now we're gonna go to the bottom of this wall, and at this level we're going to estimate the effective lateral stress and porosity pressure. So I'm going to write here, so this will be passive, and we will start at depth of 4 meters. So in this case, effective vertical stress, it's 3 meters of the soil, and soil has unit weight of 20, so that will be 60 kPa. Porosity pressure, it's 3 meters of water, 9.81. That will give us 29.4 kPa. Then effective vertical stress will be the difference between total stress and porosity pressure, and that will give us a value of 30.6 kPa. Okay, now we're going to estimate this lateral passive pressure. That will be effective vertical stress, which is 30.6, and we're going to multiply by this coefficient of passive pressure, which is 3 times 3. That will give us 91.8 kPa. I have some problem with my kPa. Okay, and I'm going to write here, so this point will be 91.8. So porosity pressure, we already found that this will be 29.4 kPa, right? So now finally we're going to estimate the total passive pressure. So we'll start with the lateral pressure from the soil. So this is half of this lateral passive pressure times the length that this pressure is applied on the wall, which is 3 meters. And then we're going to add also pressure from porosity pressure. So it's half of the that water pressure is 29.4, and again it has a length of 3 meters, so that will give us approximately 181.8 kPa, which is passive pressure. So we have active pressure, we have passive pressure. That's how we do the calculations. That's it for today. Thanks for watching this video. Have a nice day. Bye.